Every single day, industrial cake factories around the world produce over 15 million cakes using automated systems that can create, frost, and package a finished cake every 12 seconds. Behind this sweet empire lies an incredible manufacturing process that transforms simple ingredients like flour, eggs, and sugar into perfectly layered, beautifully decorated cakes enjoyed by millions. Today, we're taking you inside a massive cake factory where robotic precision meets culinary artistry. And a single facility can produce 50,000 cakes in just 8 hours of operation. Welcome back to Process Nest, where we uncover the fascinating world of manufacturing. I'm your host, and today we're diving into the sweet science of industrial cake production. From ingredient preparation to final decoration, this process combines chemistry, engineering, and automation in ways that will absolutely amaze you. So let's step into this sugary wonderland and see how it all works. Before a single ingredient enters the production line, the cake factory transforms into a sterile environment that rivals pharmaceutical manufacturing standards. Workers undergo a complete hygiene protocol that takes exactly 15 minutes to complete. The process begins at specialized washing stations, where workers scrub their hands and arms for a full 2 minutes using antibacterial soap. Next comes the protective gear, hair nets that cover every strand, disposable gloves that are changed every 30 minutes, and full-body aprons that are replaced between different production runs. But hygiene goes beyond personal protection. The entire production floor is sanitized using automated UV light systems that eliminate 99.9% of bacteria and pathogens. Air filtration systems create positive pressure environments, ensuring that outside contaminants cannot enter the production area. Temperature is maintained at exactly 18 degrees Celsius with 60% humidity, conditions that prevent bacterial growth while keeping ingredients at optimal consistency. The magic begins with ingredient preparation on a scale that's hard to imagine. A single production run requires 2,000 kilograms of flour, 1,500 kilograms of sugar, and over 10,000 eggs, all processed simultaneously by sophisticated machinery. Watch as these massive robotic arms capable of lifting 200-kilogram bags effortlessly transport ingredients to precise measuring stations. These aren't your kitchen measuring cups. We're talking about industrial scales accurate to within 50 grams, even when measuring tons of ingredients. The flour preparation alone is a marvel of engineering. Specialized sifting machines shake the flour through multiple mesh layers, removing any lumps or foreign particles while aerating it to ensure consistent texture. The sifted flour then travels through pneumatic tubes, essentially a highway system for ingredients, directly to the mixing stations. Egg processing is perhaps the most impressive automated operation you'll see. Machines equipped with gentle suction systems pick up dozens of eggs simultaneously, placing them onto conveyor belts where they're automatically cracked by precision blades. The separation of whites from yolks happens instantly through centrifugal force, with optical sensors detecting and rejecting any eggs with blood spots or inconsistencies. The mixing process itself takes place in industrial mixers that could easily hold a small car. These mixers don't just stir, they use planetary motion where the mixing paddle rotates around the bowl while also spinning on its own axis. This creates the perfect vortex action that incorporates air into the batter, ensuring the cakes will rise properly during baking. Temperature control during mixing is critical. The friction from mixing generates heat, so the mixing bowls are equipped with cooling jackets that maintain the batter at exactly 21 degrees Celsius. Too warm and the butter melts prematurely. Too cool and the ingredients don't combine properly. The baking stage showcases industrial engineering at its finest. These aren't your home ovens. We're looking at tunnel ovens that stretch over 100 meters long and can accommodate 1,000 cake pans simultaneously. The conveyor system moves at precisely calculated speeds, exactly 2.5 meters per minute, ensuring each cake spends exactly 40 minutes in the oven. But here's what makes these ovens remarkable. They maintain different temperature zones throughout their length. The entrance starts at 160 degrees Celsius for gentle initial heating, peaks at 180 degrees in the middle for proper rising, and gradually decreases to 170 degrees at the exit for perfect browning. Humidity injection systems add steam at specific intervals, creating the ideal crust formation. Too much humidity and the cakes become soggy. Too little and they develop hard, thick crusts that crack during cooling. Each oven is monitored by thermal imaging cameras that can detect temperature variations as small as 2 degrees Celsius across the entire baking surface. If any section varies from the optimal temperature, automated systems immediately adjust heating elements to maintain consistency. As the perfectly baked cakes emerge from the ovens, they enter a controlled cooling environment that's as precisely managed as the baking process itself. Rapid cooling could cause the cakes to crack, while slow cooling might lead to continued baking and dried-out textures. The cooling tunnels maintain airflow at exactly 15 degrees Celsius, with humidity controlled at 55%. The cakes spend 20 minutes in this environment, allowing their internal temperature to drop from 95 degrees Celsius to 25 degrees Celsius gradually and evenly. Once cooled, the cakes meet one of the most impressive machines in the entire factory, the automated layer cutting system. These machines use ultra-thin wire blades, similar to cheese cutters, but on an industrial scale, to slice each cake into perfectly uniform layers. The cutting mechanism is guided by laser measurement systems that scan each cake's height and automatically adjust the cutting positions. Whether the cake needs to be cut into 2, 3, or 4 layers, the machine calculates the exact positions to ensure each layer is identical in thickness. The precision is remarkable. Each layer is cut to within 2 millimeters of the target thickness. This consistency is crucial because uneven layers would create lopsided final products and inconsistent frosting distribution. While cakes are baking and cooling, parallel production lines are creating the various frostings and creams that will transform these simple cake layers into decorated masterpieces. The frosting production area operates like a separate factory within the factory. Industrial mixers, each capable of producing 500 kilograms of frosting per batch, combine butter, powdered sugar, and flavorings using precise ratios that have been perfected over years of development. For buttercream frosting, the process begins with butter that's been aged at exactly 15 degrees Celsius for 24 hours, the optimal temperature for achieving smooth, pipeable consistency. The butter is whipped for exactly 12 minutes until it becomes light and fluffy. Then powdered sugar is gradually added over 8 minutes, while the mixer runs at a specific speed that incorporates air without creating bubbles. The frosting application system is where robotics truly shines. Robotic arms equipped with specialized nozzles can apply frosting with precision that, honestly, surpasses human decorators. These robots are programmed with hundreds of different patterns and can switch between them instantly, which is kind of amazing. For layer assembly, the bottom cake layer is positioned on a rotating platform while a robotic arm applies frosting in a perfect spiral pattern, starting from the center and working outward. The amount of frosting is controlled by computer algorithms that ensure consistent coverage every single time. Exactly 150 grams of frosting per layer for standard size cakes. The second layer is then precisely positioned using vacuum suction systems that prevent damage to the delicate cake structure. This process repeats for each additional layer, with the robot making micro adjustments based on real-time feedback from weight sensors. The final decoration stage combines the precision of robotics with programmed artistic patterns that, honestly, rival hand-decorated cakes. Modern cake factories employ robotic decorating systems that can create intricate designs using multiple colors and textures simultaneously. These decorating robots use computer vision systems to identify each cake's position and orientation, then execute pre-programmed decorating sequences. The robots can pipe borders, create rosettes, write messages, and even place decorative elements like candies or fruit with millimeter-perfect accuracy. For chocolate decorations, The process involves specialized tempering machines that heat chocolate to exactly 32 degrees Celsius. That's the optimal temperature for creating glossy, stable chocolate that won't bloom or develop white spots. Robotic arms dip decorative elements into the tempered chocolate, ensuring even coating while controlling the thickness to within 0.5 millimeters. The most advanced factories can even create custom decorations on demand. Edible ink printers can add personalized images or text to cake surfaces, while robotic piping systems can write custom messages in dozens of different fonts and colors. Before any cake leaves the factory, it undergoes, this really rigorous quality control that combines both human inspection and advanced technology. High-resolution cameras actually scan each cake from multiple angles, using artificial intelligence to detect even the tiniest imperfections in frosting application, decoration placement, or, structural integrity. Plus, weight verification systems make sure that every single cake meets the exact specifications. If there's a variance of more than 25 grams, the cake gets automatically rejected, no questions asked. Temperature sensors also confirm that cakes have cooled to the optimal 4 degrees Celsius for packaging, and metal detectors provide a final safety check before anything moves forward. The packaging process itself, honestly, is a marvel of speed and precision. Automated systems can package a finished cake every 8 seconds, placing each cake in these custom-fitted containers that, protect the decorations during shipping. Robotic packaging arms use gentle vacuum suction to lift cakes without disturbing any of their decorative elements, while conveyor systems coordinate the movement of cakes and packaging materials with this sort of choreographed precision. The numbers behind industrial cake production are truly staggering. A single large-scale cake factory processes over 50 tons of ingredients daily and produces enough cakes to serve 100,000 people. The automation is so efficient that a facility employing just 50 workers can produce what would have required 500 bakers working by hand just decades ago. The precision engineering involved means that each cake is virtually identical to every other cake in its batch. Same weight, same frosting distribution, same decoration placement. This consistency would be impossible to achieve through manual production, even with the most skilled bakers. From the moment raw ingredients enter the factory to the time finished cakes are loaded onto delivery trucks, the entire process takes just 6 hours. Yet, each step involves technology and precision that represents years of engineering development and millions of dollars in specialized equipment. As you can see, the transformation of simple ingredients into perfectly decorated cakes involves an incredible symphony of automation, chemistry, and engineering precision. The next time you see a beautifully decorated cake at your local store, you'll appreciate the remarkable industrial process that made that sweet moment possible. Thanks for watching Process Nest. If you enjoyed this sweet journey through cake manufacturing, hit that like button and subscribe for more fascinating factory processes. Comment below and let us know what food manufacturing process you'd like us to explore next. Until next time, keep questioning how things are made.